Yeah, okay guys, so we learned, or we're supposed to have learned Friday, the definition of vertex, right? The vertex is a coordinate, okay, on an XY plane, and it's either the highest or lowest point of a parabola. So like, if I were to draw any parabola, the vertex would be the lowest point. So if you're traveling from left to right on this parabola, you're going down, and then all of a sudden you reach a lowest point and then it goes back up. So this would be the vertex of that example of the parabola. The parabola either opens up or down, and once you know if it opens up or down, you'll know if your vertex is either the highest point or the lowest point of that U-shaped curve. Okay, so let's go back to the opener here. The vertex is either the blank point or the blank point, highest or lowest. Highest or lowest point of the parabola, depending on if it opens blank or blank. What does that mean? Up or down, that's right. Up or down. Okay, now the next sentence. The blank value will let you know how it opens, even before the A value, right? The A value will let you know how it opens. You guys remember a standard form quadratic trinomial equation? If you have something like y equals 2x squared minus 3x plus 4, the A value tells you if it opens up or down. If the A value is positive, it opens up. If the A value is negative, it opens down. Okay, so the A value, that's the answer right there. The A value will let you know how it opens even before graphing. Okay, the next sentence. Right through the blank, the vertex, that's right. Right through the vertex exists a vertical line that divides the parabola perfectly in half. Let me write that down. Right through the vertex. So as you could see, the vertex is the most important point of a parabola. It's the highest point or the lowest point, and right through that vertex, there's a line that divides it perfectly in half. What's that line called? Axis of symmetry. Okay, an example of that on this sketch over here, if you were to draw a line, a vertical line going right through that vertex, in this case this green dotted line, that would be the axis of symmetry. It's supposed to provide a perfect reflection from one side to the other side, but this was a quick sketch, so it's kind of ugly. Anyway, let's move on to the next sentence. We are talking about the axis of symmetry. It says, we can use it to reflect blank from one side to the other. Reflect what? We can use the axis of symmetry to reflect what? Now there's a couple answers, I guess, that'll fit here. Anybody? So if I have, I guess, let's say I have a XY plane. Let's say I'm graphing my parabola. And let's say I found that my vertex was at the coordinate 3, 1. Yeah? Let me go to the coordinate 3, 1. So 1, 2, 3 on the X, 1 on the Y. Let's say the vertex is right here. Yeah? That coordinate would be the coordinate 3, 1. Now let's say I know that this opens down because the A value is negative. And let's say I found out by plugging into my XY table a couple of more points. Let's say I plugged in a couple more points and I got this point right here, and let's say this point down here somewhere. Now, right through the axis of symmetry, let me make it in green actually. Right through the axis of symmetry, the vertex passes the axis of symmetry. So here's the vertex, the axis of symmetry goes right through it. Now, what could I use this axis of symmetry for, knowing that I have these two other points? What could I do with these two other points? I could reflect them to the other side. Does that make sense? So I could take this point, which is 2 units away, I could reflect it 2 units away, and I'll get a point out here. So knowing that your axis of symmetry provides a reflection, you'll be able to take this point and move it over here, and take the other point and reflect it over there, thus producing your perfect parabola that goes through those points. So let's go back to over here. We can use the axis of symmetry to reflect what? From one side of it to the other. Points, right? Or you could say coordinates, whatever you want. I'm going to say points. Points, but you could also say coordinates. From one side of it to the other, thus saving us time when graphing. This is important to know, that it saves you time to reflect as opposed to plugging in values and doing a lot of math for each value. Once you have a couple of points, you could just reflect it on the other side of the axis of symmetry. Number two, The vertex formula is, what is the vertex formula? X equals negative b over 2a. Perfect. Okay. And remember, when you do apply the formula, replace the b and the a with parentheses, and then you could plug in your values easily. What else does it say? The vertex formula is x equals negative b over 2a, and it will provide you with the x value. Obviously, it provides you with the x value because it says x equals. Here's the question: how do you find the y value once you already have the x value? Plug in the x value. That's right. To find the y. So that's the answer you should write down for number 2 right there. After you write down your formula, that formula provides you with the x value, and then you use that x value by plugging it into the equation to find your y value. And now we get to some actual equation here. It says use the following quadratic function to answer the following. So we have y equals 2x squared plus 16x plus 31. 3a, question 3a, does the above parabola open up or down? What do you guys say? Up. Okay, good answer. Now the question is why? Because, I forgot the u, whoops. A equals 2, it's positive. And if it's positive, it's going to open up. Okay? If it's negative, it's going to open down. 3b, knowing this, you will have a maximum value or a minimum value. In other words, knowing that it opens up, what kind of vertex do we have? A maximum or minimum? Minimum, right? If it does open up, that means from left to right, you're going down, down, down until you reach a minimum point, which would be a vertex, and then you start coming back up. So knowing this, you know that you're going to have a minimum value right here. Minimum. 3c, find that maximum or minimum value. Show your work. Now, some of us are thinking, what do you mean find that maximum or minimum value? I don't even have the graph yet, so how am I supposed to know what's the maximum height or what's the minimum? Well, we don't need to actually see the graph. Why not? Because we know that the vertex is that maximum or that minimum value, correct? So if we know the vertex formula for the above equation, we should be able to find the coordinate, which would be the maximum or minimum value. So let's do that. Let's write down our formula. And then let's know how to use the formula with parentheses. And the b value is what? Here's a, here's b, here's c. The b value is what? 16. So you plug in that 16 in parentheses. The a value is 2. Put in that 2 inside of the parentheses. So we really have negative 16 divided by 4, which equals negative 4. Okay? So we have, what did we find so far? The x. We found the x. Okay, and remember the vertex is a coordinate, which is an x and a y value. The x value of this coordinate is negative 4. I still need the y value. So what do I do to find the y value? Plug it in. So I'm going to rewrite this equation, but instead of x and x, I'll rewrite it as 2 parentheses squared plus 16 parentheses plus 31. And then I'll be able to plug in my x value into those parentheses. So let's rewrite, let me do it over here on the side. Let's rewrite that equation, but with parentheses instead of x's. And inside those parentheses, I'm going to be plugging in the x value that I just found, which was negative 4. Plug it in right there and there. So negative 4 goes right in there. And then I have to do math, and we always use the correct order of operations. So there are no parentheses. I mean, they're parentheses, but there's nothing to do inside of them. So I'm going to move on to e exponents, which is negative 4 to the second power. Negative 4 times negative 4 is positive 16. Now, I'm going to keep the parentheses here to remind me that I need to multiply it by the 2 that's out here in the front. I'm going to bring down the 2. So I have a 2 out in front of the 16. And then I have the, let me bring everything down actually, plus 16 times negative 4 plus 31. So I'm going to do multiplication next. 2 times 16 is 32. And then 16 times negative 4 is negative 64. And we still have plus 31. So all we have left to do is add and subtract. From left to right, if I go 32 minus 64, I will get negative 32. And then if I bring down the plus 31, negative 32 plus 31, final answer is negative 1. So this is our y value. Remember, this whole thing started out with the equation y equals all this stuff. Instead of the x's, we replaced it with the values that we found for x. And then we simplified using math, found the answer for y. So our vertex of the above parabola, what was that? Negative 1. Okay, so the vertex is negative 4, negative 1. And that is the minimum value. Negative 4, negative 1 is the minimum value of that parabola. Now, 3D, if you wanted to graph this parabola, you need more coordinates. How could you find them? I don't even want you to do it. I just want you to explain. How could you find more coordinates? Like, so far, like let's say we wanted to graph this, because that's what the question says. Okay, here's our xy plane. If we go to the coordinate negative 4 and negative 1, we have our dot right here. This is our vertex. I could draw an axis of symmetry. I should draw an axis of symmetry right through it. But the question is, I need more points. How do I find more points? XY table, perfect, right? So if you wanted to find more points, you would go to an XY table and you plug in, it's as easy as this, plug in two values that are on the same side of the axis of symmetry, okay? So like let's say you wanted to plug in negative 3. Now why do I say negative 3? Well, the vertex and the axis of symmetry, remember this is going to provide a reflection. It's 1, 2, 3, 4 units away from the axis, from the origin. So I'm going to plug in negative 3, which is clearly on the right side of this axis of symmetry. And I'm also going to plug in another value on the right side, which would be like negative 2. Okay? So you got to look at where your axis of symmetry is at and then pick two values that are on the same side of that axis of symmetry. Now, of course, how could you find out the output for the input negative 3? You simply plug it in and work it out. Now, I'm going to stop right there because this was only supposed to be focused on vertex and the vertex formula, which we already did. On the next video, we're going to be actually going back to our notes from Friday and actually going through all the steps of graphing, and I'm going to teach you a shortcut on graphing parabolas.